Hey everyone, welcome back to Chroma.Smile.Studio, the place where we explore digital dentistry and Exocad design step by step. In today's video, we're going to look at one of the most important setup windows in Exocad, options and parameters. I'll walk you through every single option, explain what it does, and also show you what additional settings Exocad will ask for when you select them, especially the ones that require you to choose a material type or extra scans. Material shade. Here we select the tooth color A1, B2, B1, C2, etc. This doesn't affect the 3D design directly, but it gives the lab important information about the final shade of the restoration. Implant-based section. Let's go through these one by one. 1. Custom abutment. This option is for designing a personalized abutment for implants. When you choose it, Exocad will ask you to select the material, for example, titanium, zirconia, because the software needs to know what kind of abutment you're designing. After that, you'll also be asked to define the implant system and scan body information before continuing. Screw retained, used for implant cases where the crown or bridge is attached directly with a screw. After selecting this, Exocad will also ask for the material type of the final restoration like zirconia or PMMAs, since the material affects how the screw channel and emergence profile are designed. You'll also need to define the screw access direction and angulation during the design. Post and core. This option is for root canal treated teeth where you design the internal post and coronal part together. When you pick this, Exocad will ask for the post material, usually metal or fiber, because it affects how the post fits inside the canal. On stock abutment, select this when you already have a pre-manufactured abutment that's been scanned. Exocad doesn't ask for a material here, because the abutment is already defined physically. It only uses the scan for reference. On substructure scan, for example bar, this option is for cases that sit on top of a framework, such as a titanium bar or a metal base. Once you select it, you'll need to import the scan of that bar so Exocad can design the prosthetic layer over it. Additional scans. Pre-op model lets you import a preoperative scan of the tooth or arch before preparation, great for copying natural shapes. Extra gingiva scan allows you to add a separate soft tissue scan to help Exocad better recognize the gum contours, especially useful for implant cases. Additional design steps in Wizard Virtual Gingiva enables a virtual gum design used in full arch or implant-supported prosthetics. Thimble crown for advanced implant workflows where the crown covers an internal substructure, like a thimble-style coping. Copy or mirror lets you duplicate or mirror the shape of a tooth from the opposite side to create symmetry in your design. Cervical adaptation, one pull to margin, tells Exocad to adapt the restoration margin exactly to your defined preparation line. Preserve tooth library shape keeps the original form and anatomy from the tooth library as much as possible, ideal for aesthetic restorations. Before we finish this section, there are 3 more really important parameters you should always check carefully in your design setup, because they directly affect how your restoration fits, how strong it is, and how it's milled. Let's talk about them. Minimal thickness. This value defines the minimum allowed material thickness in your design. It basically tells Exocad, don't make the crown or coping thinner than this value. If during design the software detects that any area becomes thinner than the set value, it will highlight it in red or warn you during the validation step. For example, for zirconia, a safe minimal thickness is usually 0.5 to 0.7 millimeters for interior crowns and 1 millimeter for posterior crowns. For veneers or thin restorations, you can set it lower, but always based on the material's manufacturer recommendation. In short, the minimal thickness protects the restoration from being too fragile or breaking after milling or sintering. Cement gap, also called the cement space, this defines the tiny gap between the inner surface of the crown and the prepared tooth. This space is necessary for the cement to flow evenly and for the restoration to seat properly on the model or in the mouth. If the gap is too small, the crown might not seat completely. If it's too big, you'll have poor retention or uneven cement thickness. Typical values are 0.05 millimeters 50 micrometers for very precise restorations, 0.08 to 0.1 millimeters for standard cemented crowns, and sometimes 0.12 to 0.15 millimeters for temporary materials or resin-based designs. In summary, the gap width controls the internal fit and cement flow of your restoration. Reduction depth. This option controls how much the tooth is virtually reduced or cut back during the digital design. It's mostly used when you want to design a coping, framework, or a cutback design for veneering. For example, if you want to create a zirconia coping with porcelain layering, you might set a reduction depth of 0.8 to 1.2 millimeters. That tells Exocad how much to remove from the full contour before generating the reduced coping surface. Basically, the reduction depth defines the thickness of the porcelain or veneering material that will sit on top of your framework. Now let's talk about another option you might see in some cases, virtual extraction. This setting usually appears when you're designing a restoration for a tooth that's still visible in the scan, but you want to digitally remove it before starting your design. Basically, Exocad asks you, do you want to perform a virtual extraction? Yes or no? Here's what happens. If you choose yes, Exocad will automatically remove or cut out the original tooth shape from the scan data. This is perfect when you scan the patient before extraction, but you need to design a crown, bridge, or implant for that same area. By virtually removing it, you create space to design the new restoration exactly where the natural tooth was. If you choose no, the existing tooth will stay visible in the scan during the design. This can be helpful when you just want to reference the old tooth shape, for example, to copy the morphology or position, without deleting it. So in short, yes equals digitally removes the old tooth from the scan used for designing replacement restorations. No equals keeps the original tooth in place useful for reference or copying shape. It's a simple choice, but it completely changes how the 3D data is handled in your workflow. So make sure you select the right one based on your case type. Alright, that wraps up today's tutorial on Exocad's options and parameters. We went through everything step by step, including material shades, implant-based setups, additional scans, design steps, minimal thickness, cement gap, reduction depth, and the virtual extraction option. If this video helped you understand Exocad better, don't forget to like the video and subscribe to Chroma.Smile.Studio. Because here we focus on fixed prosthetic designs, crowns, bridges, implant restorations, and all the detailed workflows behind them. So if you're into professional dental CAD design and want to improve your Exocad skills, this is the perfect place for you. Thanks for watching, and I'll see you in the next video.